Welcome to lesson 4.2 on isosceles and equilateral triangles. Let's take a look at example number 1. The only thing that they are trying to point out here on this one is that if you have an isosceles triangle, remember that means you have two sides that are congruent. So I've got BC congruent to AD, then that means these two angles are congruent. We identify that by saying the angles opposite these sides. So what angle is opposite side BA? C. Angle C is opposite. What side is opposite side BC? Angle A. So these two angles are congruent. If you drew a line of reflection right here through this, we call this the vertex angle down here, then you could reflect the triangle over and you could demonstrate that it is congruent by that transformation. Then let's take a look at your next theorem related to that, isosceles triangles and the converse. All they're saying here is if these two sides are congruent, then these two angles are congruent. If these two angles are congruent, then you know that the two sides are congruent. So that's where we get the converse in here. Then they give us an example of a problem here where we're told that this street length is congruent to this street length. And they're doing some city planning here. They've got a pool. They need to control erosion and put a cobblestone path in each of these corners. We know this one is 50 degrees. So what are the other two? Well, if First Street is congruent to North First Street and South First Street are congruent, then we know angle E and angle F are congruent. So I take my triangle angle sum theorem, all of these together equal 180, subtract 50, I'm left with 130, and I take that 130 degrees and divide it evenly between these two. Each angle is 65 degrees. Now we've got example 3. They're asking us to use the converse of the triangle angles, or the converse of the isosceles triangle theorem. So here we know that these two angles are congruent, so therefore we know that these two sides are congruent. Then I can do some math to find the value of x. This side, x plus 20, is equal to this side, 8x over 3. I set that up. I solve that and get 12, and then I plug in 12 for each of my values. PR here is congruent to RQ, so I would expect their measures to be the same. Work out the math and check yourself, and then PQ has a different length. Then let's take a look at another theorem down here at the bottom, theorem 4.2. They say if a line or line segment bisects the vertex angle of an isosceles triangle, then it is also a perpendicular bisector of the opposite side. What? That sounds like we're trying to cram every geometry term we know into one theorem. So let's be clear. A line or line segment bisects. It cuts into two equal pieces. The vertex angle. A vertex and a vertex angle are two different things. A vertex is a corner. The vertex angle of a triangle is the peak angle. Okay, so it is opposite the base. So this vertex angle gets bisected. That means it cuts this angle into two equal parts of an isosceles triangle where two sides are congruent. Then this line is also a perpendicular bisector. It's perpendicular, and bisector means it cuts this into two equal parts. So if AB is congruent to BC and ABD is congruent, or the measure of ABD is equal to the measure of CBD, then we know that BD is perpendicular to AC, and we know that AD is congruent to DC. Now let's take a look at a real world problem. We've got a house here that they're trying to move. And we know that along the route there is a bridge that has a clearance of 17 feet. We need to figure out if this house is going to fit under there. We know each roof line measures 16 feet. We know that the base of the house has a height of 10 feet, but we don't know how far it is from here to here. We know the base of the house is 28 feet, which means the base of this triangle is 28 feet. If I bisect this vertex angle, that means these two sides are congruent and these two sides are congruent. If the whole thing was 28, now each of these is 14 and 14. They drew that in this drawing here. And so now we're just going to look at one triangle at a time. So we've got this triangle, 16 feet on this side. That's our hypotenuse of a right triangle. This side is 14 feet, and this one we don't know. Since it's a right triangle, we can use our Pythagorean theorem, a squared plus b squared equals c squared. Our c is going to be this hypotenuse here, 16. So when you plug that into there, you find out that the height of this triangle is 7.7. Does that mean the entire house is 7.7 feet tall? No, just this portion of the roof is 7.7. This portion, we're told over here, is 10 feet tall. So 10 feet plus 7.7. The driver's going to have to find another route. This house will not fit under that line. Then you've got the concept here of an equilateral triangle. All they're saying is if all the sides are congruent, then all the angles are congruent. Okay? So, and they also tell us if the angles are congruent, then the sides are congruent. Let's look at example 5. Prove that equilateral triangles are equiangular. All you need to do here is once we know this is an equilateral triangle, which means it is also an equiangular triangle. So that means if we cover up that congruent mark and we know, let me flip this over, there we go, and we know that's an isosceles triangle, then these two angles are congruent to each other. Now I can reveal, oh, let's look at it this way. So what if these two are my congruent sides? Well, then that makes these two angles congruent, and now all the angles are congruent and all the sides are congruent. In letter B, they give you a proof, if you know the angles are congruent, showing that the sides are congruent. Then this example here, you're going to need this. So you have a lot of questions about this on your homework. So if angle CBD equals 130 degrees, so let's put that, I put that in this drawing over here. So this whole angle here equals 130 degrees. I don't know, are these two congruent to each other? Is this one 100 degrees and that one 30? I don't know. So, but I can use what I know here to calculate the rest of my information. So they show me that angle, if I know that this is an isosceles triangle, then I know that this angle is congruent to this angle. Those two base angles are congruent to each other. Then I can figure out that this, they tell me, I can find out here that, oh, if all three of these are congruent though, then the three angles are congruent. Okay, so what's the total of all the angles in a triangle? 180. So 180 divided by 3 is going to leave me with 60 degrees per angle. So this is 60, this one is 60, this one is 60. Oh, now that I know that this side is 60, then that means the other side of this is going to be 70. So now I know this angle is 70 degrees. If these two are congruent, so I'm going to ignore this triangle for right now. If these two sides are congruent, then these two angles are congruent. And I can say, oh, well, if this is 70, I need to do 180 minus 70 gives me 110. And I divide that by these two because they are congruent, and I find out that each of these equals 55. They want you to do the same thing here with this triangle, STUV. So if I know this is 72, then I know that these two, so If I know that's 72, then I know these two angles are congruent. There's my two congruent sides, so these are my two congruent angles. I just take 180 minus 72, and then I divide all of that by 2. So I get 108 divided by 2 leaves me with 54. Each of these is 54. Then this is a linear pair right here, and I can figure that out, and I'll do the other angle the same way. They just give you a concept summary here. Isosceles triangles. If the sides are congruent, then the angles are congruent. If you bisect the vertex angle of an isosceles triangle, it's only true for isosceles triangles. If I bisect the vertex angle here, I get a perpendicular bisector down there. And equilateral triangles, if the sides are congruent, then the angles are congruent, and the reverse is also true. Okay, thank you for listening.